Welcome everybody for this session of EPIC new product release. It's a very interesting meeting where we will touch different photonics technologies. And yeah, to be really concrete, we go straight to the point. I introduce the first presenter, Mr. Amauri Mendoza from Scitodate. He will show us about their platform to monitor and to know about what is going on into the scientific market, in the photonic scientific market. So, Amauri.
Hear me okay?
Yes, yes, Amauri.
Awesome, perfect.
Yeah, maybe I just introduce the other four gentlemen. Then we will speak about plastic optical fibers. Then we go to some profile measurements from specialty optical fibers. And then from fibers, we will go to the laser business meeting, first for JET and then a workshop of photonics to speak about laser processing and laser processing services. So welcome, Amauri. So the floor is yours. Please tell us what you will give us and what you need from EPIC members.
Okay, thank you so much for having me in this presentation. I'm really excited to present you guys what we do here at Scitodate, so that you guys can get a better idea on how we're helping the photonic industry to grow. But we try to do it from a different perspective. So let me just start presenting from my side. So this is a question that you hear every day when you have a meeting. Can you see my screen, first of all?
Yes, sir. Clear.
Okay.
Please go to presentation mode.
Yep, I put it in there, so it should be okay now. Perfect. So let me give you a bit of an introduction of what we're trying to do. So we are trying to change the way that go-to-market strategies are being done, but as well as how marketing and sales is being done within the photonic industry. And the way that we're trying to do that is by implementing something that we like to call centralized market intelligence management. As of right now, how marketing and sales is being done within this industry is that you got a lot of feedback from different systems. So that is your ERP, your CRMs, and your supply chain management. That gives you a lot of internal data that you can use in order to make strategic decisions. So for example, okay, how are you going to sell your specific product or instrumentation, but also how to go to a specific type of market within an application area if you want to. So all that information comes as of right now from all your internal system that is being recorded by your salespeople, marketing people, and your whole organization internally. Now, what we want to do and what we have developed already is that we want to become that market management system. What does that mean? Is that now we're able to look into external data. And what we mean by external data is think about grant data that is coming from different grant sources, but also scientific publications, which is a lot, which is going to give us an idea on how the market looks like. So think about this as your point of truth. Now you have internal data that you can make hypotheses about it, and then you have external data. And when you combine those two, you can increase conversions around the whole organization. That is by understanding the market that you're going to go into. Give you an example, if you're going to go to a certain application area, in there you can have how big is the market, how many people are in that market, and then you have a whole map to understand and use this information to your advantage to have this perfect strategy to increase all of your revenue across your whole organization. This is why a lot of people, when we started within our process, they thought, oh, this is just a tool to give us more leads coming from scientific publications. However, they easily realized that we are more than that, and they saw that we are basically a navigation system. Because now we can tell you with a certain amount of certainty, hey, this is the way that you should go within the market. This is how you should talk to certain potential clients that you want to approach, so you can use that to your advantage and increase conversions, let's say from a marketing qualified lead to a sales qualified lead, all the way into closing by understanding really your customers and the data that they are writing about and what they're interested in. And you can apply this on different levels. So how does that look like in reality is that, for example, we have 3 areas in which we can add value, like I mentioned. So the first one is product strategy. Because of the data that we have coming from the scientific publications, since we have millions of there, we can understand how your specific instruments are being used, but also your competitors' instruments are being used. So you can start doing a lot of market segmentation, but also start developing your own instrument based on how your customers are mentioning that within scientific publications. Then we go a level down, which is the product marketing part. And this is when you start becoming much more operational from a marketing perspective, meaning that you will understand which accounts to actually go after, or which institutes in this case. You can start making micro-targeting strategies or market targeting campaigns. This will allow you to really focus on the needs of those customers based on the scientific publications that they have published, which will increase your conversion. And then finally, the sales operation, by you understanding that actual customer, that will allow you to have better conversations with them, actually talk about the research and what they're doing, and how we in the photonic industry can potentially help them achieve their research much easier, much faster. And how the product looks like is that we first give you data about the market as a whole. Then we try to give you much more data on a much operational level. So think about the scientists that you want to approach. And then we make that data in a format that actually allows a salesperson to understand all of that much easier. So this is how it actually works in theory. I wanted to also show you fairly quickly how that looks live, so that you guys have a better understanding of that. So in here, for example, this is the analyzer that I was mentioning. I did a bit of a example on ultra fast laser, just to keep with the theme of the presentation today. So in here, we are able to see how many authors are talking about ultra fast laser, how is that divided over the year. In here, you can see where are those authors located and where they're publishing from. And then you can see the institutions from which they're publishing for, so that you can really understand, hey, if I know that the Osaka University is talking about that, maybe I should go and talk to them. On a more operational level, that means that you're able to see who actually is talking about that, and you can understand their work and how that looks like. And then you can have all the information that you need about that particular person to understand that person on a much more deeper level, so you can have a better conversation. This also results on you guys getting daily notifications when a grant is being awarded to a person, so you can be the first one to understand, hey, this is the person that I should be discussing with at this point in time. So this is what we do in a nutshell. I don't know if you guys have any questions.
Thank you so much, Amauri. So this is very impressive presentation. I think that, yeah, I would like to hear the question from the attendees. The first person that maybe I invite to say something is Eugen, an example. What do you think about? It could be useful for your job.
Yeah, thank you for asking me. But yeah, at the moment, yeah, it's difficult. I think it's yeah, something more be maybe for yeah, what we can discuss internally. But for the first point, yeah, I think maybe you need to analyze everything more, and how you could implement it, how it could help you in your or in our organization. Yeah, but for the first, from the first impression, it's difficult to say.
Yeah, by the way, just introduce Eugen. I just catched him, but Eugen is here and is representing MPS, one of the greatest company about micro positioning system for optics. So clearly they are really engaged with all the photonics environment, and they need also to understand where to address their efforts from sales point of view, but also from business development. So this is something that maybe you can bring home to think about.
Yeah, of course. It's always interesting to hear about new things, new approaches to business and to sales, and yeah, for sure. I will take that. Thank you.
Somebody else would like to ask Amauri something more detailed. Don't shy. Really, nobody? You have to elaborate this. Let's take this and think about. In any moment, you can reach Amauri directly. Feel free to exchange the addresses through the chat of this meeting. And in any moment you want to reach Amauri, feel free to contact me or my colleagues at EPIC, and we will introduce Amauri. So just to not lose the momentum, let's go to the next speaker. Great. So it's a pleasure to introduce César Esteban from company KDPOF. It's a great development in plastic optical fiber. And so I stop talking and I leave the floor to César.
Thank you very much. Welcome, everybody. Yes, I'm introducing the KDPOF KD9351, which is our first automotive fiber optic transceiver. Firstly, I'm giving a brief hint about the KDPOF company, which was founded in 2010 in Madrid, in Spain. We are 28 employees, from which most of us are engineers. We are a fabless company, okay, and we are specialized in digital, AMS electronics, optoelectronics, and optic designs. We are members of standard entities such as ETSI, ISO, and IEEE, where we are standardizing physical layers for communications in Ethernet over plastic optical fiber and glass optical fiber as well. And we are members of a Japanese Automotive Association, JASPAR, and the Ethernet Automotive Association, Open Alliance as well. Our key products are optical transceivers, transimpedance amplifiers, and LED drivers. I'll explain to you later that we are also moving to also VCSEL and for the next generation technology for higher bit rates. We have one of the most important suppliers in the wafer manufacturing and packaging and also testing as well. And our main markets are mainly automotive, but we are also targeting home networking and industrial applications. We are our headquarters are in Madrid, but we have other locations in France and other parts of Spain, and we have commercial offices in Europe and Asia mainly. So typically the demand of high-speed communication are increasing. So if we take an example of video in high definition, we see that we are approaching or even trespassing the typical or historic barrier of 100 gigabit per second per meter, which is agreed by most of the people that is the limit when optical start to make sense in a link in a communication link. So we can see, for example, a link of 4K with 60 frames per second will require around 12 gigabit per second, and in the case of a 10-meter link, we will be above this limit, and an optical communication would be required because it makes sense in terms of cost. It also makes sense in terms of engineering easiness, And we are analyzing here what is the limitations that copper links are having as we are increasing the rates. The approach to reach these higher bit rates is adding more parallel lanes and having larger conductors with shielding as well. Copper communications are increasing the complexity of their digital signal processing for forward error correction or equalization, and they are having higher signal amplitude. All these have impact in the cost and in the weight of the cables and the connectors. Also, the decrease in the mechanical flexibility of this harness. Copper communications at these high bit rates have a higher power consumption and a high latency as well. Not only that, there is a very important topic here. As the bit rate increases, the copper communications, the copper links are having more and more trouble in EMC compatibility, electromagnetic compatibility, I mean. So optical communications bring a cost-effective solution that brings some flexibility to locate high data rate components in optical locations in your PCB board. The size, the flexibility, mechanical flexibility of both the harness and the connector are decreased a lot, and it allows an easier installation and routing of the cables. It will have a lighter solution, lower weight, which will provide a fuel efficiency. It's a future path for higher bit rates in the future. The glass fiber has even the plastic optical fiber has a very good mechanical performance with the bending, the vibration, and so on. And it's much superior when we compare in terms of electromagnetic compatibility. Of course, this also at high bit rate, it has a lower power consumption and a higher link reliability compared to copper links. So on the left column here, I want to present what is the current technology of KDPOF. And on the right side, you have the next generation, that is the project we are now working, what we are developing now. The current technology is for 1 gigabit per second and 100 megabits per second. And we are moving for the next generation to multi-gig, up to 50 gigabits per second. The current technology is based on infrared LED, step index plastic optical fiber, and the PIN photodiode. And the next generation we are developing is based on infrared VCSEL, OM3 multimode glass optical fiber, and a smaller and faster PIN photodiode. Okay, the performance also improves with the new generation technology. It moves from 40 meters without any inline connector in the link, or 15 meters with 4 inline connectors. We move to 40 meters with 4 inline connectors, which is a much higher performance than the current technology. Both the current and the next generation are based on CMOS semiconductor technology. The target bit rate is 10 to minus 12, and the ambient operation temperature is from minus 40 up to 105 Celsius degrees. Here is a very schematic view of what KDPOF does. We are applying advanced digital signal processing to optical communications to reach harsh environment applications. What we see on the left side of this screenshot of an oscilloscope is the signal that is received after going through 40 meters of fiber at 150 and 25 Celsius degree of ambient temperature. And what we have on the right side is that signal after applying this advanced digital signal processing from KDPOF, okay, which is the core, the know-how of the company. So you can see that we can open the eye diagram and recover all the data that is transmitted that otherwise could not be received and decoded properly. So what I want to present just to finish is the new product we are launching is the KD9351, which is a fiber optic transceiver, which has a transmitter and a receiver. You can see on the right side, this chip here with the two holes. One is aligned with the LED for infrared light in 650 nanometer red visible light, and the other hole is the receiver, which is this hole is aligned with the photodiode, and then it goes the signal to the transimpedance amplifier. Okay. This is the physical medium dependent sublayer that is connected to the rest of the blocks of the physical layer according to the IEEE 802.3 VV standard. Okay, this transceiver that you see here integrates in transmission the LED driver and the LED, in reception the photodiode and the transimpedance amplifier. And it's important that there's also an EMC metal shielding inside this chip that makes it really with a superior performance in terms of electromagnetic compatibility. These are the features, the main features. It can operate at 1 gigabit and 100 megabits per second. It supports wake up and sleep. It's optimized for plastic optical fiber. Target bit error rate is 10 to minus 12. It's low power, low cost. It's grade 2 of AEC-Q 100 automotive qualification. And the package is LGA with 36-pin package. Okay, and just to finish, this is the connector that is put on top of this transceiver. That is a snap fit connector that does not require any soldering. And you can see on the left side the evolution of different connectors along the time. And you can see there has been an important reduction in the size of this connector. Okay, that is important for mainly for OEMs and tier 1 in automotive market. And the pitch has been reduced from 6.2 millimeter to 4 millimeter. It's a general port down size for the connector. And as I said before, this connector is just pure plastic, which is a low cost and easy solution because all the EMC shielding is integrated inside the KD9351 chip. So that's the summary of this product we are launching. I will be more than happy to answer any questions you may have about the KDPOF technology or about this specific KD9351 transceiver we are very proud to introduce here in this EPIC event.
Yes, thank you so much, Cesar. Very interesting and impressive technologies. I have several questions, but first the floor to my colleague Tracy. She is the specialist of optical communication. So please, Tracy, make your question first.
Thank you so much, Antonio. And Cesar, is it Cesar or Cesar?
Cesar, it's okay, yeah.
Cesar, okay, thank you so much for this presentation. This was fantastic. There were a couple of things that before we get to the EPIC questions that I thought were really remarkable. And also I have some questions on applications. So can this cabling system be used to communicate for the ADAS, or can it also be used for communication to sensor fusion? Can it basically replace all of that communication cable within the automobile?
Sure, sure. In fact, we are moving from an old technology that was known as MOS, that was focused only for infotainment applications. And now with this technology from KDPOF, now we can cover a wide range of different applications for in-vehicle network, like, as you say, ADAS, camera links, smart antenna modules, even the backbone of the whole network, which is moving to Ethernet, because the temperature range has increased a lot from -40 up to 105. So you can have lots of applications in the in-vehicle network, not only the infotainment that was restricted for the old technology based on plastic optical fiber, yeah.
Yeah, and so not only the entertainment network, but more importantly, especially for these autonomous vehicles, the network that's required in order to make the decisions and receive information from all of the sensors around the vehicle and help decide when to stop, what information to send to the rest of the network, and to be able to handle the bandwidth that will be required for this. So it's far more than infotainment. This is really exciting. And I really appreciated seeing your board, because I was thinking about the fiber. So it's wonderful. It's plastic fiber, it's lightweight, it's low cost. These are all important aspects for electric vehicles. But in addition to that, it's going to be much safer for electric vehicles. It's going to be much cheaper and much lighter weight, which translates to a lower power budget overall for the car. So this is wonderful. I'm very impressed. And I'd love to see it live. But before we go on, we have two EPIC questions. So what can you do for EPIC and what can EPIC do for you? Perhaps what partners are you looking for the next step? So what do you think?
Well, one of the most important targets we have in the automotive industry is to make the optical ecosystem grow, okay? Because together with this technology, there should be also different suppliers of harness, of connectors, or even test houses or tool vendors for testing and validating and qualifying the optical solution. So for us, it is very important to send this message that we are looking for companies that are eager to make this optical ecosystem grow, mainly in this automotive market that we are focusing, but also in other markets such as home networking or industrial applications as well. Regarding your previous comment about electric vehicles, yes, I fully agree with you. In fact, one of the most valued features of this technology is that it provides galvanic isolation, and it is being considered, in fact, is in production for important European OEM for battery management system, where it's important to have galvanic isolation between the high voltage and low voltage domains, where we're talking about very high voltage levels. And from the safety perspective, it's also important to have an optical communication with a dielectric media in the middle that isolates both ends of the link.
I think that that's excellent. Certainly, we do not want to be sitting in these electric vehicles and receive a very bad electric shock. So I think that you have some incredible applications that you can use just within the vehicle, including lighting, including the communication system for autonomous driving, including your infotainment, and then, as you mentioned, other applications for industrial manufacturing. So I think that having a good price point and having a solution that is not copper has incredible opportunities, even going into 5G and antennas. But what can we do for you? What would you like? Do you need?
Well, what I said is it's important to have these contacts to make the ecosystem grow. Okay, because otherwise it's not possible to have an important weight in the automotive industry. So it's important that we have this networking of different companies that are focusing the automotive market, mainly in the optical applications, to work together, and EPIC maybe can collaborate in this, okay, to have to show a little bit the path and make this connection between different companies to make the ecosystem of optical communications in the vehicle grow.
Sure, that is a typical task of EPIC, and I think that the first thing that is coming in mind is that a meeting that we will have in 3-4 weeks is about automotive lighting, but really automotive lighting is a more general topic, because now lighting is not just the headlights, but really is going to ambient lighting, infotainment, and so on. So this is really something that is important, because now photonics is really stepping into automotive. But really here I would like also to make maybe the last question before to go on. You said about industrial application. So maybe if you can just give some example, and also tell us if you have also something about other segments like healthcare or scientific.
Yeah, when I talk about industrial applications, I'm widening the spectrum of applications, from transportation for trains or avionics. Also healthcare is, or medical applications, where the EMC and galvanic isolation is important. Okay, there are very stringent requirements in terms of electromagnetic compatibility, both emissions and immunity for medical equipment. And here it's optical is the right path to go for this kind of applications. For example, in industrial application, robotic arms benefit a lot from this kind of links, where, for example, the plastic optical fiber has a very high degree of mechanical flexibility, and allows a much higher life for the harness that maybe has to withstand important mechanical laws of dynamic bending or so on. And these kind of applications are perfect application killer for this kind of links.
Great, great. So
I would imagine, Antonio, even some applications for laser machining, whether it's laser machining or laser micro machining, for the harness to be able to provide feedback for the cameras for monitoring of the melt pool. So I think that there would be many applications for this, and
I will say
it's
that
exciting.
especially for laser machining, optical fiber is a well-known component. I will say that in all the laser cutting machines, they are using plastic optical fiber to bring critical signals around.
This is a very good example. This is a very good example for this kind of optical links. Yeah.
And that is really a typical example. Not so wide, because laser cutting is not a huge market at the end, but probably is a good example where photonics has been used first by photonics devices. But let's go on, because we have to keep the pace. There is a lot of other interesting topic on our desk. So we will remain in the fiber optic domain, and we go to the next speaker discussing about how measure the fiber optics. This is another critical topic. So I leave the floor to Edward Robinson from Arden Photonics, and we will learn about metrology, a measurement device for fibers.
Okay, thanks, Antonio. All right, you can see my screen? Okay, so first of all, let me say a little bit about Arden Photonics. We're a company working to design and manufacture innovative test equipment and components for the photonics industry, and specializing in metrology equipment for specialty optical fibers and also multi-mode launch conditions. And we've been doing that based in the UK near Birmingham since 2001. But what I want to talk about today is our latest product. I'm pleased to announce the NPA 400 Refractive Index Profiler. So this tool it's designed to be a way to get the refractive index data that you need for whatever purposes, for specialty fiber design and manufacturing or other uses, but to get it quickly and easily. And we do this using what we're calling a modified refracted near field technique. And what's special about this is that it enables in one shot to get a full picture in 2 dimensions of the refractive index over the full end face surface of your optical fiber. So what's special about this? I think the most important thing about the NPA to say is that it makes performing these refractive index measurements much more simple, much more quick than has ever been possible before. So, we can perform a measurement on a fiber sample in just a matter of seconds, and actually preparing the sample for the measurement is also very straightforward. It's just a case of stripping, cleaning, cleaving the fiber, and then placing it in our specially designed fiber mount, present it to the instrument, and you're ready to go. And when you do that, as I said, you're going to get a full 2-dimensional profile straight away without any need to do, raster scans or data reconstruction. All of the data is there instantaneously. You can use it to measure fibers up to 400 microns in diameter. And because of these properties I've been talking about, we think it's especially well suited to measure fibers that have been, previously poorly served. Specialty non-circularly symmetrical fibers. I'm talking about, polarization maintaining, octagonal fibers, multi-core fibers, all sorts of things like that. And all of this is backed up by a traceable calibration. So I just want to show you a measurement in real time to give you an idea what I'm talking about. So this is from the point that you're loading the fiber into the system. It's automatically focusing on the end face of the fiber. Then once that's done, we start the measurement, and in just a few seconds, you'll see there, what you've got there, that's the refractive index measurement of the end of the fiber, and that's ready to start analyzing with our built-in tools, or of course, all of this data is fully available to export. So as I said earlier, we think this system is really well suited to measuring a wide range of specialty and standard optical fibers. So I just wanted to show a few examples of some types of fiber that we've tried it out on ourselves. We've looked at octagonal fibers, graded index multimode fibers, polarization maintaining fibers, multi-core fibers, but this is just a small selection. We've measured fibers up to 400 microns in diameter and as small as 40 microns in diameter. So it's really suitable to a wide range of different fiber types. So yeah, in summary, the MPA 400 is the fast and easy measurement solution to get you full two-dimensional refractive index profiles for your whole range of standard and specialty optical fibers up to 400 microns in diameter. Thanks very much for your attention.
Thank you, Edward. This is another very interesting devices. Frankly speaking, I worked along on fiber business, and this is something that I really liked a lot to have in my laboratory, because always fibers is a key element for laser and signal transportation. And so it was always really tricky to understand exactly which is the real behavior of the fiber. And yeah, I will have several questions, but the first one is that I saw that here we are going up to 400 microfibers. So we are speaking also about large multimode fiber. So which is the typical target market that you have in mind? Or another way around, the typical epic question: what you could do for the other, and what you would like the other helping you?
Yeah, so I mean, I think you're exactly right. We see this as a product that's going to open up refractive index profiling to a wider range of people than have had access to it before. So, you know, rather than just being a tool for fiber manufacturers, this could be something that yeah, users of specialty optical fibers might be able to apply. And yeah, so we want to be able to make this measurement as accessible as possible. In terms of yeah, what people can do for us, I think, you know, we've developed this instrument, but we want to make it as easy to use and as comprehensive a tool for, you know, the whole range of specialty optical fibers. So, you know, I think what would really help us is information on what direction these fibers are going in, what are the parameters, what are the features that are really important to users, what analysis and measurement tools should we be adding and developing?
Sure. Maybe I would like to ask also the help of the other people in the room. But yeah, the first thing that is coming in mind to me is really how to transport laser beams, and also what could be the effect of the fibers on the laser beam. So anybody would like to comment about laser processing, and also to comment what they would like to know about the typical transportation device between the laser and the point of application. Maybe I will invite, if they like, the colleagues that will present later, but also the other one. Which is your needs from this point of view, so we can support Edward. Yeah,
You're going to
basically.
shoot me, Antonio. I'm sorry.
No,
So I have
we need an icebreaker.
Well, I have two questions. So would this be applicable to the telecom market? Like for PON or other fiber applications?
Yeah, I certainly think so.
I think so as well. How about, can you measure hollow core fiber?
Yes, that's something that we have looked at. Obviously, I wasn't able to share any images of that because we've sort of done some kind of confidential measurements of hollow core fibers. But yeah, that's something that we're interested in for sure.
Excellent. Okay, that's all from me, Antonio.
No, but
thank you, Edward.
This is an interesting point at telecom. But really, here I saw that is a really wide range because 400 micron is a wide range of application. So I think that the people, for the moment, they have to elaborate the concept. But yeah, I think really interesting and potentially with a wide range of application, the tool. So please, as I said before, feel free to contact directly Edward, or if you want, you can contact me and I will introduce Edward in any moment.
Thank you.
So, thank you so much. Unfortunately, I'm a laser guy, so I'm in love with laser. I really appreciate a lot to introduce the next presentation. We Thomas from Forjet, and he will speak about their job shop services, a very key element to use more and more laser processing.
Yeah, Antonio, so thank you for the introduction. Welcome, everybody. I hope you can see my screen and my presentation.
Perfect.
Very good. Yeah, today I want to talk with you a little bit about our subcontract laser processing as a service for you. As some of you maybe already know, is background of Forjet is that we are a company who supply industrial production machines for different applications and markets. I would like to keep the top part because I have the presentation will be shared later on. I will go directly into the markets and different applications where Forjet can help you out with job shop services. So we have at the beginning, tire manufacturing. There we are talking about laser cleaning, surface preparation, but also marking for traceability and quality inspection. The second part is also automotive industry and general industry, where we have the laser cleaning again, and surface preparation means really like tire molds, cleaning the tire molds, remove rubber from surfaces or different other kind of layers. Then as a third part is all the glass and thin film, so laser cutting, laser drilling, laser patterning of glass is one of an application where we can provide the processes for and new businesses. This is something where we take a look also into the future for processes for surface functionalization. And today I want to talk more about our micro machining job shop services. So, but first, just to show you where the different hubs and locations of Forjets are, we are generally with our headquarter and production located in Alsdorf. This is near Aachen in North Rhine-Westphalia. Our job shop production is running in south of Germany, something like 70 kilometers from Munich away. And we have also different hubs in Atlanta and Shanghai for all the sales and service guys for maintenance of the production machines who are at the customer place. So then I go directly into the different applications we can offer with our machines in as a job shop. First, I want to show you all the laser cleaning and surface preparation and what capabilities we have there. We have different machines where we are able to provide the first one. It's a machine for tire mold cleaning. But with this machine, we don't have only the possibility to clean tire molds, means remove the rubber from the surface. We can also remove or clean different molds, also molds from different deposition processes or deposition chambers. This is the main application for the first machine. Second one is everything who is laser marking on wound parts, mostly on tires, bring QR codes in it, make DOT codes. There we have also the ability to read out the tire itself and the locations where we have to laser at. Next machine is more kind of flexible machine where we can implement different holders to make ablation surface treatment of, for an example, batteries for electrical cars, or also for different parts in the automotive who have to be cleaned after some, let's say, painting, and where on some position painting have to be removed on. This is a capability we have with a robotic system and an infrared laser. And the last one from the laser cleaning and surface is our handheld system, where there the main application is really when you have parts where you are able to transport the parts because they are, say, a fixed location or something like that, where we can bring the lasers and directly to the part itself, who have to be cleaned, and where we can work on with a laser. Next applications we have, this is everything who is more related to the glass itself. This is the laser cutting, drilling, and patterning. There we are able to provide as a service all the cutting of glass from 30 micron up to a few millimeters of glass thicknesses, where we are able to make some freeform cutting. There are some different designs possible. Here, what we work with is most of the time to get designs from the customers as a normal graphical file, and this is something we can then introduce into the machine and cut it out of a piece of glass. Patterning is also something we provide, where there we have the possibility to ablate selectively different layers on glass who are deposited in to, for an example, to be able to make some electrical wires into the glass to bring current on the right position where you need it. Our drilling, this is then something where we make the inner contours within glass. Here we have the ability to make different shapes, also work on different glass thickness, up to 4 millimeters of glass thickness, and where different applications, like also in the medical lab on chip devices, we can bring holes into glass itself. Here are some of the different markets where we can provide our services. First one is the healthcare, as I already said, so like lab on a chip, microslides, macrofluidics means that this is most of the time certain wafer-based size, and we are able then with our processes to cut it down to the end part size which is needed by the customer. Second application is optical glass, where we have lens arrays, where we are able to cut it, or also the architectural glass is standard glazing smart glass, but also in the solar market, there we provide the processes to remove some layers on glass where you have, for example, to bring two glass or glue two glass together. There we can remove the different layer to be able to glue on the glass surface itself. And yeah. Next one, automotive transportation glass. That's more so windshield. One thing is cutting out a smaller glass out of a big glass, but when you think of a windshield in the new cars, you have all the detectors in the middle, like the camera, infrared cameras, and so on. And normally you have different kind of layers on windshields who have to be partially removed for the sensors to be able to see through the glass itself. And this is a process we provide also. Yeah, display glass means, like you see it here, for interior in the car, cutting out glass panels also for machines. It really depends a little bit on the application of the customers and what their needs are. And also then at the end, this semiconductor, so wafer glass, cutting, drilling the wafer glass as needed from the customer side. Yeah, job shop. Why should you ask us for job shop? Background why we are offering the job shop itself was that we saw with the time that a lot of potential customers were not able to do the invest in a laser machine due to missing project sizes. Where, yeah, let's say to justify the investment in a laser machine was not there. And this is the reason why we said, okay, good, we could help you to open you to the world of laser processing and to help you to start with smaller projects with us. And then with those projects generate further bigger projects where at the end of the day, you would be able to make the investment in a machine. Beside that, we would be also during this projects learn from each other where the possibilities of the laser processings are, where the limitations, where you can implement the laser in your production, what kind of maybe also new products you could build up with the laser processing. So means that our job shop services is also something where we want our customers to learn the capabilities of the laser processing itself. Yeah, and at the end, also the services is built up because of backup for service, for maintenance in your production when you already have laser systems, or also when you reach your production capacity is 100% and you have new projects, and it makes no sense at this moment in time to invest in a new machine. You can do all the production capacity with on top what you can do at our location. And this is something then we are also able to provide with our job shop center here. Good, yeah, and I think overall I come to the end that we are really open, that you come back to us with your application, with your thoughts, with your ideas, and we'll be really thankful if new ideas could be generated from the community from EPIC.
Okay, great, very great presentation. It's like, for me, it's like to be a children in the candies shop. There are so many laser processing applications that are really incredible. Really, I like a lot of this application. And I just try to summarize a little and then I make a question. So let's say you are open to accept any challenge from the photonics technology, photonics community. So any crazy idea to make something with laser, probably you are open to test and to find if it's applicable. So to find the potential application. Is it correct? So you are open to make any kind of laser processing, cutting special materials, or also surface structuring, surface preparation, and so on.
Correct. Yeah. This is also a little bit the idea of the subcontract services we offer, is also that people come back to us with their ideas and that we can then discuss with the customer if it is possible or what would be needed to have the right laser sources, the right components to reach the needs. Yeah.
Okay, great. So here I will say that I like a lot the approach. So here we see a company, a large company manufacturing laser processing machines that is also finding a route to promote the laser processing by services. So services here are, let's say, initial testing, but then all the ramping to large volume production and even to act as a source for the customers. So I like a lot of these technologies.
Thank you.
Somebody would like to make some question about maybe Thomas, if you can stop sharing so we can.
Sorry.
Okay. And then it's also interesting to make more or less the same question also to work of a workshop of photonics, that in this case is nearly the same. Clearly, everybody has to shape its own business model on their company, but I like a lot the idea to have companies providing laser processing services. This is a key topic for it.
And I think to your point, I'm sorry, excuse me, Antonio.
Yeah, please, go on.
Okay, sorry, there's a bit of a delay. To your point, I like this job shop capability as well. So you're basically extending the simple prototyping into a job shop, which in turn can help fill that gap until customers are comfortable with it and interested enough and have enough volume to be able to purchase your systems. So I think that it's a very intriguing path for product ownership, as well as providing you with income for the projects themselves. So it's more than just a prototype, it's doing services. I like this as well. I agree with Antonio. I do have another question for you though.
Yeah.
What is the pulse repetition rate of your lasers, and are there certain lasers that you tend to use for this precision micromachining?
Yeah, but it's a little bit depends on the applications itself. So what we are working with is from CV CO2 laser up to picosecond infrared laser in different wavelengths. So means that at the end we choose the right laser for our machines for the application needs of the customer. In our job shop itself, we have some, let's say, products where we are working with, who we also provide, where there we have fixed for the laser cutting, it is picosecond laser sources. For laser drilling, it's infrared, green nanosecond sources. For all the surface applications or surface cleaning applications is more in the range of nanosecond high power laser. Yeah, it's really a little bit depend on the needs, but at the end we are able to choose the correct laser for the applications. If it have if you need a better quality or more throughput and not such a good quality, we can yeah, let's say integrate the laser we want into the machines.
Yes, you are really playing a relevant role, because really you are, let's say, the cutting edge key player in this case, because you are really understanding and translating the customer needs that at the end of the day a manufacturing company would like to produce something into a concrete process. So selling processes, and you know probably better than anybody else the laser parameters. So do you have, for example, a special wish about laser? Which is the laser that you miss, that you still miss? So this is a challenge. Unfortunately, we have no laser company in this meeting, but okay, it's better. So tell me, okay, this is a little too early for a Santa Claus wish, but okay, we look forward.
To be honest, at the end of the day, it's a cheap laser.
Oh my God.
No. What we see, and this is also something was quite important, is that with the time or with the years, the laser sources itself becomes more affordable for the people, and regarding this also for the different applications. So means that some applications where we are using the laser today were not thinkable of 10 years ago, because the laser was 10 times the prices. And means that regarding the laser sources, what we see there is really that with the time, the laser get cheaper, the markets get bigger, and also the application have a certain growth, because now it makes sense to use a laser where earlier you weren't thinking of to work with it because it was too expensive.
Yeah, sure. Okay, let's say the pressure on the cost is always a typical manufacturing pressure, but let's take it. So we are really going a little slower than supposed. So we can talk a lot about, but then we are more or less on the same topic. So even if we exceeded a little the scheduled time, I would like now to introduce a workshop of photonics. Sorry for the bad spelling, Laurynas from a workshop of photonics will continue about this topic. And then I have another tricky question for him about laser sources.
All right, perfect. Right, so let me just jump to the presentation view. Right, so you're right on the point that we are, well, a bit on the same page, but have our own uniqueness. So what I want to show everyone today is our unique element that we made. Well, unfortunately, we don't have laser manufacturers here, but that's not only for them. This is what we do and how we solve the solutions that are in the optical designs using the unique technology that we have in-house to alter characteristics of the light in overall laser systems. But a little bit background, so you would be on the same page with us. Who we are a company that has extensive knowledge professionally and personally. We have a lot of personnel coming from the background of engineering and physics, mostly in lasers and material sciences. And we have been active for a while, and nonetheless, we are growing quite fast, which is nice to us. So over these years, we gathered knowledge in specific fields for application of ultra short pulses. Therefore, well, at least we like to tell that we are focusing on the micro tasks. You can do most of the things with more than one technology these days, but we see our uniqueness in the applications in broader sense that require sub-millimeter features and accuracy on 1,000 times below the millimeter or so. So how this works in our company, and this is to acknowledge the 4Jet approach as well. We also start from the prototyping step, because we have standard components and products that we make in-house. However, all the companies in high tech, they have their own challenges that they want to overcome. They have their own designs that they want to make real, because the customer in the end is the one that tells what the market needs. And this goes the same way for optical companies, for biomedical companies, for all the giant companies in the world. So we usually start by the task with whatever kind it might be. And before you come to the conclusion that you need the system, or after you come to the conclusion that you don't need one, but you need a company that would supply the OEM services to you, we do the contract manufacturing services that can also be, in broader sense, all kinds of processes that require laser solution for your microtask. And then, of course, we do industrial laser systems together with R&D systems for versatile purposes. But getting back on the topic, and here are some companies that already use our solutions. As mentioned, laser companies, biomedical companies, and many kinds of them. But today we're focusing on lasers and what kind of challenges these kind of customers have. So, and you already touched this, and this is nice. So femtosecond lasers or picosecond lasers, they are all moving towards how to make the product better. That means how to have more power, how to have higher repetition rate, how to be unique in the market, and how to be better each day. This is, again, all coming from the market. So there are many kinds of approaches. You can do that using different laser types. But for compact, stable solution, many clients choose solid-state lasers in which your active medium is crystal. So what happens in that specific crystal? You try to have more light in it. The more you try, the more thermal effects are affecting the crystal. Interestingly, that all happens as the nature dictates it. So you actually have some symmetricity there. Therefore, you have actual gradients, actually symmetrical gradients of the temperature. And this is coming to the challenge itself. So what happens? You have to compensate everything because you have the polarization of your medium that affects your laser, and you're losing the laser capabilities in general. So what we do, we are solving the problem for laser depolarization. Therefore, we call the product that we're introducing today the polarization compensator, because all of this is happening not on purpose, but it happens symmetrically, which means you can figure out the pattern and you can compensate that symmetrically again. So our company is working on unique technology that lets us use the same kinds of lasers to write the structure, which would again bring the light back to the status that you want to have it. So we write the structure inside the fused silica glass, inside the volume. You have one tiny piece that solves the issue, which otherwise would just result in the effect that you wouldn't want to have. So you guys can look at the charts here, but there are a bit more visual things, how this works. Essentially, you have the laser beam that you want to have a nice ideal shape. You don't want to have scattering, which is also solved by this technology. You also do not want to have some very complex structure of the element, or you certainly do not want to have bulky structures. So all of this is done in single element inside the volume that as the outcome solves the issue of the pricing. So it can everything be done in single element, which is easy to handle, stable, has high LIDT value. That means if you have the laser for industrial purpose and it is naturally planned to run 24/7, then you wouldn't have any issues there because of fragility or whatsoever. So how this looks like, yeah, so you can see the picture here. It's a bit stylized. Actually, it's just glass, which you barely can see the structure because it's optimized for efficiency. So you don't have scattering, meaning your eye cannot really see the structure too much. It's just a little bit blank there. So this one is a bit stylized. But what we can offer these elements for specific laser types. So you can actually choose the wavelength that you want to have the compensation for. You can choose the size, depending on what kind of medium size you have. You can also choose additional things that we can offer to you, anti-reflection coating that would improve already naturally good qualities of the element. And since this is pure glass, doesn't really matter with AR coating or without, it has, well, extremely high LDT value, which means you do not have to worry about damaging the element over time. However, same method can be used to do all kinds of structures. So these are just patterns you can come up with with your imagination or challenge you have. But what I want to emphasize is that really there are challenges that you don't really get to know before you meet the client. So I encourage everyone to think through what you're using and what you're trying to solve in the long term or short term. But there are probably the solutions where you do not expect to have them. So this is one that we are offering to our clients that look for optical solutions. But again, we do have solutions for all kinds of micro tasks. So this is it. Thank you for your time. Try to be last, but quick.
Thank you so much.
Positive.
Thank you so much. I'm really impressed. I'm really speechless because I played a long time with lasers, but this really was really a key element to solve a lot of issues, especially when you work with high power short passes. That's really crazy element. So I understand that I think that everybody understands what you provide. This is a great tool to improve the output beam of the laser. So I would like to ask you what you need from the EPIC member and the other people, because here the offer is quite clear. You offer a unique device for ultra fast laser. What you need?
Nonetheless, not only for ultra fast lasers, it is compatible
High
with
power.
all kinds of lasers. Yep.
What you need? Tell us shortly what you need, and also what is the key collaboration factor that you would like to get from our community. Are you thinking to special segments, or can we improve some special application?
Is that a question to audio? Or
Yeah,
to
I will say to all of you, but especially to you,
all right.
Laurynas. So what you would like to, which is your wish list in this case?
Well, in this case, the wish list is to test more kinds of the laser types. We have already partners and customers that test these elements inside their products already for ultra fast lasers. But what I think we are trying to acknowledge is to give a look from different perspective. We are using ultra fast lasers ourselves. It is very interesting to see industrial lasers that potentially have similar or different challenges that they didn't think could be solved. They most likely take it as it is. This is the way it is. So our nice to have, top one wish list thing is to get to know more optical designs of internal of the lasers and what kind of optical tricks tricks or challenges are there. Yeah,
very fine, very well. Okay, so I kindly ask you to stop sharing. So okay, we can talk very long on all of these exciting topics. So we started from a very interesting platform to have a different approach to the market and to the business. Then we went through optical fiber, and then we reached ultra fast material processing. It was really interesting. Really, I would like to thank all the speakers and all the attendees, but really I would like to thank especially the speaker that made with us this fantastic journey. So Amauri from Scitodate, César from KDPOF, Edward for Arden Photonics, Thomas from Forget, and last but not less important, Laurynas from Workshop of Photonics. So I thank you all for this exciting journey and invite all the other EPIC members to apply for future meeting on product release. Thank you so much for this excitement.